Hello, everyone. Welcome once again to the Shiny Conference. Greetings from Houston, Texas. I'm really excited to introduce our next speaker, Michael Rubin, who is going to be talking to us about ODAPES. A little bit about Michael. He grew up on a small farm in Switzerland. He now lives in Sao Paulo, Brazil, and he's a member of the MIT Action Group for Climate Change. Michael, you have the floor.
Hi, hello everyone. Thank you very much, Ian, and a warm welcome from the beautiful country of Brazil. And yeah, let's talk about farming. Myself, I'm a farmer originally, and we are using our Shiny to do what we call democratizing digital agriculture, to give access to the digital technology to smallholder farmers. So I will be speaking half of my presentation time about our business, our impact we are having on the community, and the other half about the technology, our Shiny we are using. Well, let's go ahead. I want to start with a rhetoric question. This is a picture of our local supermarket. You see on the left-hand side a piece of meat, and on the right-hand side some tomato. And what you notice that they have almost the same price, it's about $4. And it's kind of surprising if we see how many resources go into each of these products. You see much more for every kilo of meat. So why is that? Why do prices or food prices not reflect the resources we are using to produce them, right? So I want to go ahead and give the answer straight away. The answer lies a bit in how our farms are structured, our farming community is structured. You see here two charts on the left-hand side. I have, both charts show the number of farms in percent, or the distribution of the farms. And on the y-axis, you see the size of the farm. So here are the very big farmers, and on the bottom, the very small farmers. And you see the red pictures is the US, and you see kind of a healthy demographic distribution, right? And the big guys here, they mostly produce soy, corn, and cattle. So they are producing the meat. And then the veggies are often in many countries produced by the small farmers, you know, the guys down here, like tomatoes, cucumber, and all the stuff. And if we look at the same map or the same graph on the world, we see a completely different picture. We see almost nobody in this part here, and we see a lot of people down here, right? And now the point is, which answers the resource question, is in the last 50 years, almost all the innovation, chemical technologies, digital technologies, all went to the top part, right? So, and I see this is the biggest reason for this big divide, this big disconnect we have today in our food producing system, right? And that's exactly the point we are addressing. Our goal is to bring innovation, digital innovation down here to this part, to the small guys, right? We are talking about 540 million farmers. We're talking about around 1 billion jobs worldwide, and we're talking about 10 to 15% of the CO2 emissions. That's all kind of affected, and of course the food we are eating every day. So, and we want to help these guys to jump to the next level and get access to our modern world. How we are doing that? We have a theory of change. So this shows like a new project at ODAPES. Whenever a new project is opened, we kind of open two tracks. One is a commercial track. We attend here mid-size farming businesses which go digital. They use our Shiny toolkit to produce their own platform. And then on the bottom, we have the smallholder farming communities. These are typical NGOs, can also be farming cooperatives, which is quite common in Latin America. So these are groups of 100 to 500 farmers, typically most very poor, very small. And so we have local experts there. They are getting, the point here is these commercial guys here, they are sponsoring the projects down here. So whenever we have a commercial sale, we will have also a smallholder community gaining access for free for the same technology, right? And that's the way how we try to give equal access to both of these segments. Long story short, that's the theory of change in action. One of our first projects we see, I start on the right-hand side. This is the company called Sumit Agro. It's a mid-size farming input company doing some chemicals, some biological fertilizers. And here we see myself with a representative of them. We did the platform. This was a business for us. And all the other pictures are from an NGO in Nicaragua, which is called Centro Empresarial Pelas. They're working with these very small farmers. You see here, this picture, the second from the right, is the Shiny platform for themselves. And then here you have the training we are doing. That's a very important part. We need to see how the knowledge gets actually across to the farmer, right? And then you see the results, how they're adjusting the irrigation system here in the last picture. According to the recommendation we created with Shiny, right? And of course the results, some nice tomatoes, which they produced. And that's actually the way we are working. So we're really trying to connect technology with the farm and real down to the earth, right? Well, what is the way we are providing agronomic information? There is one very well proven solution. This is the crop consultants. You know, these are these guys. They go into the field. They know the area. They know the region. They know the crops. And so what they're doing since a long time, they are collecting data in the fields. They're putting them in their spreadsheets. They're doing some agronomic analytics. And then they provide the services. This can be reports, this can be fertilizer recommendations, can be yield predictions to their farmers, right? So the point here is it's a manual service. It's a painful process to do all these analytics in a spreadsheet and kind of copy paste the graphs over to the Word document, print this out, send that, and that's why these guys. They are expensive, right? So only the big farmers can afford to hire them, and small farmers don't have access to this valuable resource of knowledge. So, and that's where we want to approach and change something. So we take exactly what we're doing. My co-founder, Dr. Rodrigo, he's a crop consultant for 25 years in Chile. And we're taking all these models, algorithms, which are working well, put them into a Shiny app, right? And this Shiny app then allows that we can replicate this and create platforms for many small agronomists, local consultants, so that they can have access to this knowledge, to this technology, go digital, and provide services out to their clients. This can be typical people, which small businesses, they have like 20 clients, 20 farms which they attend, or right. So that's actually our model. So let's take a tour now. Now we go a bit more into the Shiny part. I am jumping over here to our base platform. So we just start away. What we're doing here is we are going now through a very small process of how a crop consultant would make a fertilizer map out of some sample data he collected in the field, right? All the stuff he would typically do in a spreadsheet. So we are here in Chile. Sorry for that. So we have here a field. You see, we use Shiny tree, and in this field, it's called Campo La Rosa. We have, first of all, a field boundary, a polygon. Then we have some layers of data. These are now point data. I will just take off this one. So you see each of these points is some value. This is now soil compaction. So what we are doing now from these collected data points, which have been uploaded via spreadsheet, we can now make a map. So we go here, we select the field, we select, this is the name of the sample data. We select an algorithm, we kind of improve the resolution a bit, so we run it, and yeah, done. So it creates a new map. I can give it a name. That's a map. For example, I can associate a variable. Oh, sorry. A date. And here we go. So, by the way, this little model window is always when the user has to wait. We want to entertain them, so we give them a very small chunk of agronomic knowledge so they can learn something in this time. And yeah, now we have this heat map, to how people are calling it. It's actually nothing else than these points, but just plotted to a continuous map. But now this is not the end of the story, because what you typically have, small farms that don't have modern equipments where they can just upload this raster file map and then apply a variable doses, and they need it simplified. So that's what we're doing next. We take again this map here, we just some variables here, and what we're doing now, we are dividing this now in three simplified classes of these values. Out of this continuous map, I just have made now high, middle, and low, right? So this is now a polygon. It's not anymore, no longer a raster file. And now we have the last step. We have now kind of simplified zones, right? And now the last step, we would apply a doses. What I will be talking next then is about these microservices. By the way, whenever I call one of these windows here, I call a microservice, which is running on a AWS Lambda function, and we apply these computationally expensive functions there, right? So what I'm doing here, we have now a fertilizer doses. We know that we want to apply like 50 kilos per hectare in the average, but we want to distribute that a bit better than just all across the field the same doses. So we put that in, and now we have here a map. We can give it, this would be nitrogen, right? The major crop fertilizer. And here we go. Now it created another map. Now we can go into the layer here. And we have this one here, right? And what we see now, of course, it takes the same zones. It looks like the same, but now we see, okay, in this zone, you're gonna apply 80 kilos per hectare. So because that's the where we have the efficiency of N. And in the green part, you only apply a bit less, right? And now he can go the next step, kind of the final step would be the consultant goes into the administration pane, and he can share maps. That means share in Spanish here. Can take this map, can take a client. I would send it to Nilo in this case. I would say, okay, that's your map for this week, and you are allowed to download it. Done, right? So that's the whole story, which replaces the whole spreadsheet, making PDF and stuff. And of course, you can then also print out an R Markdown, but I won't go through that now. We won't have the time for this. Well, so a bit more into the details after we saw how this Shiny app works. What is our big tech challenge in farming? We do not have one big problem. We have millions of small problems, right? The agronomy is so complex, and I think this picture here represents it well. There are so many agtech startups in California, in Brazil, in Europe. They say, hey, cool, let's use machine learning and do some yield predictions. That's great. Let's solve these problems with a centralized platform. And that's then the typical answer. Well, good luck. These are the datas here. I mean, every line would represent 1 year. And don't forget, 1 year is one observation. One observation is 1 year in farming, right? So you will never have big data. You would probably need to wait 10,000 years to collect data before you can start doing machine learning. And you have a lot of influencing variables like soil types, climate factors, and all stuff. So it just doesn't work the way we would use machine learning for, say, marketing algorithms or something like that. So that's the point, and that's really where Shiny can help us, or Shiny can shine. We are taking kind of the open source idea, the community idea. Here we see a kind of a matrix, a table, where we have on the horizontal axis all the sectors. We have here an app by sector, right? E-commerce, logistics, and so on, and agriculture. And in the y-axis, we see the app function. So in each industry, you have a base app. Shiny is excellent for this. Then you have tidyverse, data handling, you have the dashboard, user handling, you have data visualization and all stuff. And what we are doing actually is nothing else than this. We are just turning it 90 degrees, right? We want to do open source packages and some business packages and just applying them across agriculture, not across the different functions, right? So that's like the idea we are taking, and of course, well, that's the result here. What ODAPES actually is a toolkit which allows people, small businesses, to do their own digital agriculture platform for 10x lower than normal cost. It's a modular system. We use open source. We use microservice architecture, and we do a lot of parameterization, and then so that allows us to be very competitive, to be really adjusted to the local market. And yeah, this is the kind of how the system is structured. We have the app logic, which are basically, most of them, not all, are open source packages. We are just working to get them on CRAN. And they are doing basically the app logic. They're putting up an R Shiny and adding the map, adding a dashboard, adding all the stuff you need to have just a bare app, right? Then we have the agronomic algorithms, which are microservices, which we call whenever they are needed. They are not open source, so they are just microservices from AWS Lambda. And then each of these boxes here represent another client which has a known Shiny app, totally different style. Each one has a CSS, each one has different parameters. So we just our goal is to make different Shiny apps, just changing a few parameters and not changing the whole code each time, right? Oh, sorry. A little spotlight on one of our key technologies we are using. We have been working a long time to find out how we can make R faster in these expensive computational functions like the ones you saw, right? And we all know the weak and the strong points of R. And what we found out that the AWS Lambda functions, if we set them up with an R runtime environment, is a great solution because it just does it in parallel. And so that's what we're using. Whenever you saw one of these functions running, these microservices, it actually called an AWS Lambda function. And it also allows us, from the commercial point of view, to control the usage of these microservices and to charge by use, right? So that's much. Most of these companies don't have a lot of capital. They need. For them, it's good that we can build the stuff as their business grows, as they consume the algorithms. And yeah, that's how it's structured. Our instance, then the API gateway, and all these. These are the 4 microservices I just used before. Each of them is on a separate Lambda function. Well. To close my speech here, I want to make or highlight 3 points. First of all, the big problems we have in the world, and in that moment I'm referring to the food and climate challenge in the agriculture sector. We only can resolve them together. There is no single company, not even Bayer or any other multinational company, which can solve all these challenges alone, right? So we kind of need this. Let's solve the pandemics together. Everyone does some part of the technology. We need this mentality for the next 20 years, right? And what I would call community experts, which wanna help contribute, wanna get some connections with some smallholder farmers, wanna test out their idea. You're welcome. Also, people, great programmers which want to test out some ideas, you're welcome. And also, if you are thinking about doing a business, maybe you have some R code, some R algorithms which are solving parts of these problems. We would actually invite you to contact us and see if there can be a mutual fit, if we can collaborate in some way. What ODAPES is kind of like a highway going to these small farmers and providing technology to them. Right? So with that, I would close my speak and pass the word over to Ian.
Hey, Michael, that was such a great presentation. What an impressive Shiny application. For anybody at home, I've had the opportunity to talk with Michael ahead of time, and really the impact of this is just barely being visible here. But we've got a couple questions for you, Michael. The first one is for me, and I didn't ask you this at any point in our conversations, but where does the name ODAPES come from? Is that an acronym, or does that stand for something?
Yeah. It's an acronym. It's called Open Digital Agriculture Project for Equity and Sustainability.
Okay, fantastic.
And it sounds good in Spanish, right? It sounds good in Spanish. So we are in Latin America.
And we also had a question that came in about whether or not you're using Leaflet for the base map. And I also wanted to add on that, because when you open the app and then there's that zoom in, I've been using Leaflet for years and I've never been able to do that. Can you speak a little bit about how that amazing animation was done?
Yeah, we are using Leaflet, yes. We are using Leaflet base and Leaflet extra for doing the drawing, the polygon drawing stuff. And the zooming, yeah, it's a challenge. Maybe you noticed that at some point it jumped a bit over to the weather part. That was not intentional. We are just going through in the reactive through a processing. The stuff is loading, and we have different steps. And in each step, I just trigger I'll call a trigger, and that then triggers the next observe event, and then it stays in this waiting position, and whenever I give the okay, it zooms in. But it cannot happen before I load all the maps, for example, right? So you have to control the process, otherwise it's jumping around yeah.
Well, yeah, I'm sure that was a technical challenge. Great job with that. We had a few questions kind of related to, like, how did you get started in this project? And given how mature this application is, how long did it take you to develop that?
Oh, thank you. It's a great question. ODAPES actually didn't start with R. It started with a traditional approach. It went wrong. Let's say the costs went out of control. We aborted and we rethought the process. And I learned about R Markdown at that moment. Say, hey, that's great, because exactly what farming consultants do. They are spending a hell lot of time, making these reports out of Word, and say, hey, that can be a great idea. And in the first month, just wanted to do some reporting, some reports helpers for these consultants. Oh, there is a Shiny app. I didn't know about that, but that's kind of the same, just doing an app. And I learned that myself. I learned that in about a year or so, and we are now 2 years down the road, and 1.5 years with Shiny, right? And so that's more or less the time we had to hear. It was the first 1 year was me and myself, and then I got Nilo, which is which is looking after infrastructure, the Lambda stuff, all these big challenges we have. So it's like 2 years more or less, which are in there in this project. And I really would say, if I compare this with other startups doing similar apps, it's a great efficiency advantage we have, and thanks to Shiny. I want to say thank you very much, and my appreciation to everybody which is contributing to this great community, and we really want to give back something to you guys, to everybody which is interested in this farming part with Shiny. We see it's a great fit, and it changes the world. It's
Thanks for that, Michael. Next thing that I wanted to bring up, so you mentioned in this talk about AWS Lambda and this micro service infrastructure. And as you were doing the app, I know that there's an amazing amount of complicated things going on in the background, and that the efficiency you found wouldn't be possible without something like that. So I don't know how many people here know about AWS Lambda. I know that most people here probably don't know that you can build custom R Lambda runtimes. I know, Michael, you said that Nilo was perhaps going to be with you today. Can we get him on to speak a little bit about that process?
Yeah, I will just pass it over to Nilo. I would just say something to context. In the beginning, I was thinking, well, microservice architecture is exactly what we need, because we want to replicate doing this modular architecture. It wasn't possible really at that time, but now Nilo came with this great solution, and I will pass the word over to my colleague Nilo here.
Hello, guys. Good morning. My name is. Hi, Ian. How are you doing?
Good, well.
So first of all, thank you again for this opportunity. The Lambda function, there's some documentation about some custom runtimes, and the idea came from I was doing some research about how we could do multi-processing in R. So we use non-blocking code, so the person that is using the app could continue using it as the calculation was going on. I heard about Shiny Worker, which is an Epsilon package, but unfortunately, I think it's not available yet. So the solution we got was to put it using HTTP requests, creating an API endpoint, which takes the arguments of a function, like the whole map as a JSON file, gives it to a custom runtime using a containerized R runtime, do all the calculations, and with the future package, using a future promise function, we can make a pop-up if, for example, it uses a very big map. The ones that Michael used as an example were very small compared to the farms that we are used to working here. So it will take some time to run all these calculations. And after the calculation is complete, the user will only get a pop-up, like calculation ready, and he will go and access the map.
Thank you for that, Nilo. That's really fantastic. And to anybody who has a main takeaway from this, not only the impact you have, but the way you're approaching this is really next level. Congratulations, Nilo and Michael.
Thank you.
Thank you.
So moving on to some of these other questions, we had another one in the chat that said, did the operations that we did in Shiny have an effect on the crop, or did we just collect data and make predictions, or are we taking intervention based on this data?
No, it clearly has. You have to put it to context. Farming is slow. Clocks are ticking very slow. Things take 1, 2, 3 years to develop on the field. But as you saw maybe in the third slide, in the pictures I showed about the Nicaraguan guys, there are real impact, and this is maybe one key point of our business is we need this local person. And the guy which you saw, showing Shiny on the whiteboard there, this is what we call the local domain expert, and we need this guy. The farmers don't go by themselves into the app and take out recommendations. You need to have this local guy, and he shall make a business out of it, so he can live out of it, and that has impact. They just adjusted some irrigation. What is one very concrete an example we are doing is, you probably all heard that fertilizer prices are going through the roof at this moment. That is a big threat for many small farmers. They have not the cash to run their whole fields anymore. They cannot buy enough input material. So what we're doing, we're taking the last 5-6 years of NDVI maps that tells us in a field, let's say 10 hectares, which are the parts which perform best, right? So then we make an optimization function and say, okay, given that you have only, I don't know, $5,000 of cash to buy fertilizer, what are the parts of the field you should be planting, and the rest, forget about it for now, right? It's like a damage control solution, but it saves existences, right?
Thank you so much for that, Michael. I think we have time for one more question from Thomas. Are you planning to develop further agronomic API services to build on this platform? For example, my team works on modeling ammonia emissions from agriculture, something that would be great to build on top of this. And an additional question on top of that, are these API docs publicly available anywhere?
The first question, absolutely, yes, resounding yes. It's actually a basic premise of ODAPES that we cannot solve all the problems on this world. We are, for example, we are well in soils, we are well in geostatistics, but we are not good in epidemiology. So whenever you guys, I don't know, a crop professor, PhD, whatever, a small business feels that you can do a great prediction algorithm or a great disease modeling, hey, we are here. We would be happy to integrate that, see how the business is going, do some sharing, whatever, and let's go to the market in that way. We don't have a kind of a fixed structure. We are not AWS yet, so like it's like that. We still have to work out how we cooperate, but let's talk about that. And the second is, man, we are completely lacking in documentation. You have to apologize. We don't even document the parts of our own code because we just like quick. The business takes actually off quite quickly, so we are running behind. But we are doing that. Yes, we are doing that.
Well, you're not alone, Michael. You're not alone. I guess to wrap it up, if somebody wanted to get in contact with you, what would be the best way to do that? Through your website or LinkedIn?
Just send me an email. I don't know if if our emails have been published or not. Otherwise, I would.
We can publish that in the chat in just a minute here. If that's
I would if you like make available the presentation. I just made the slides in a PDF, including my contact data, and then everybody could access it. Can be public. I'd be happy to share it.
Okay, fantastic. Once again, Michael, Nilo, fantastic job with this, and thank you guys so much for being here and presenting your work. And we really look forward to seeing what happens next with ODAPES.
Yeah, and thank you very much once again to the whole community, to you guys at Epsilon. You are really inspiring. By the way, you are inspiring us a great deal. And also the whole community, maybe you don't know it, but we use your stuff. And it's really great. It's our secret that we can do what others do in 100 lines of code. We do in 3 lines of deep layer. It's our competitive advantage. Thank you very much.
Thank you, Michael. Have a great day, guys.
You too. Bye.
Bye-bye.
Bye-bye.